Well, let's get started. Welcome to our 16th Fireside Chat. I'm Craig Galati with LGA, and I want to thank you all for showing up and continuing to show up to these important conversations. We began these chats as a way to connect our clients and our colleagues together around important issues that face our community, and to explore how we as designers and community members could work together to create great places. So before we jump into it, there's a little bit of logistics. So we do have a chat feature, but we also have a Q&A feature. So we'd like you to go ahead and ask questions throughout. Please put them in the Q&A, and at appropriate times throughout this thing, I'll break in and ask a question. We do have a little bit of time at the end, and we'll ask the balance of those questions at that time. So one other item is that this chat is being recorded, and it'll be available in about a week on our website. So if you want to come back and watch it, and please do so. It'd be great. So Jason Jajorian, my partner in LGA, is going to be interviewing our panelists today. And I have the distinct opportunity to go ahead and introduce them. But tonight, the subject of the Fireside Chat is designing for a warmer world, the supply and demand for water in the West. So there's no question that we've all noticed the shrinking levels at Lake Mead, and that we are in a constant drought that's been going on for a long time. Water is so important to us that live in the desert, and it's so important that we start to have conversations as a community about what do we do and how do we do it better. When I think about this, it's important because water is needed to sustain all of our lives. It's needed for us to assist us in accomplishing a variety of tasks. While older buildings that we have may not possess the infrastructure to conserve water to the degree that's currently needed, there are strategies that we can use to adapt these properties, as well as design for the future in a place that's going to be continuing to get warmer and water is going to become more scarce. So we're so excited to have a great panel tonight. Our first panelist is Doa Ross, and she's the Deputy General Manager of Engineering for the Las Vegas Valley Water District and the Southern Nevada Water Authority. She joined the organization in 2000, but currently is responsible for executing the design and construction of the critical water projects included in the Water Authority's major construction and capital program, as well as the district's capital improvement plan. Doa is a graduate of UNLV, a licensed professional engineer, and has served on many committees and boards in the areas of innovation, engineering, design, construction, best practices, and materials performance. Thank you for joining us today, Doa. Our other panelist is Erin English. Erin is the practice leader for the firm Biohabitats, and she leads the integrated water strategies planning and engineering efforts. She applies her background in both chemical and environmental engineering with her passion for water, ecology, regenerative design, to help clients advance innovation in one water-oriented infrastructure planning and design. Erin is also a licensed professional engineer, and she's led wastewater, gray water, rainwater, and water reuse engineering for award-winning projects that have achieved Living Building Challenge, Net Zero Water, and most importantly, they embraced the value of water and watershed thinking. Thanks for joining us, Erin. And then we also have Mike Bernardo. Mike began his career with the Bureau of Reclamation in 2011 as a mechanical engineer for the Lower Colorado region. Since that time, he served as the region's chief of staff from 2016 to 2019. He served as the Lower Colorado Basin's regional river operations manager from 2019 to 2021, where he led a team of hydrologists and engineers regarding reservoir policy development and implementation in water releases at Hoover, Davis, and dams. He currently serves as the deputy chief of the Boulder Canyon operation, which has oversight of the river operations, modeling, and research groups. So Mike is also a licensed professional engineer. He holds degrees in both from both New Jersey Institute of Technology and UNLV, and he's currently pursuing his doctorate in public policy. So Mike, thank you very much. Jason, I'm going to turn it over to you to get this thing going.
Thanks, Craig. I think we're outnumbered engineers, architects, Craig. This is just first time ever in our fireside. But seriously, I'm really excited about to touch upon this important topic within our valley. We have a great group of panelists, very knowledgeable, we all have a lot to learn. So without further ado, let's kind of just jump into the content, and hopefully we have equal time with everyone to kind of share their knowledge and hopefully their experience on this topic. So Erin, I want to start with you. Will you please explain the current condition of water scarcity in the Southwest? And, what should we expect in the future as continual climate change happens around us? Erin, you're on mute, so you want to jump on.
Okay. Making sure I've got the mute button working. Sound good?
Good.
Okay, great. Thanks for joining, everybody. So on the whole, I should be clear that I'm over in New Mexico, and so I'm going to provide a regional perspective. And I've been reviewing some of the EPA and the IPCC documents around what's expected here in the Southwest when it comes to climate change and water. And as we know, the picture is, as one recent article says, terrifying. But I don't think that we need to come to this from a place of fear, but it is good to have a reality check of what is projected to happen. So in the Southwestern United States, which where the way I'm considering this, and the EPA is from the Pacific Ocean, so from California all the way over here to New Mexico and south to the Mexican border, and up through even the lower part of the Rocky Mountains. A couple of primary impacts that are important to understand here is that much of the water in this southwestern region is highly dependent on snowpack and the way that the snow cycle works. And so one of the major challenges that is coming is that those snowpack depths are projected to decrease potentially significantly, as does the timing of when they actually melt. And so decreased spring runoff and a shift in the riverine patterns that are draining that snow into downstream systems. That also has a tie to the soil moisture picture, and a decrease in soil moisture is already happening and is projected to increase significantly. And that soil moisture part plays a large role in wildfire behavior, which then in turn plays a role in reduction of runoff or flash flooding and changes to the water cycle of how we are able to capture and keep water in our landscapes here in the Southwest. This is all happening with increases in temperature and some of the more things that we hear about, heat and drought, right? So those are all kind of compounding, along with an increase in projected population growth through the mid-century here of about 70%. That's what the EPA is stating. And so those impacts have pretty significant challenges for us when it comes to figuring out how to work through water in the Southwest. There's a great quote actually from Southern Nevada Water Authority, is that the situation we're facing isn't drought, it's the long-term aridification of the desert Southwest. So these plans that we're making and going to talk about today need to be permanent, and we need to shift our mindset in that permanent direction also. And so as we work through that, there's a couple of challenges that make just the natural hydrological cycle seem pale in comparison. So this variety of water rights that are different in each state and how those are administered and how they're counted. There are compacts that go across the various states, and there's also some really interesting senior water rights that belong to Native American and Indigenous communities, and a different way of looking and viewing at water in those communities. And so all of these different entities need to be finding ways to work together when it comes to managing what is projected to be a dwindling supply that's going to come at us in different ways than what we've been, all of our infrastructure has been built to deal with.
Well, thanks for setting up the challenge, right? The regional challenge, Erin, and explaining in a kind of a systematic approach, because I think the topic today is water, but it touches on so many different areas, and it's different factors affect population growing, one of them. And so how is this regional effects affecting Lake Mead and the Colorado River? So Mike, I want to turn it over to you and maybe talk a little bit about the current conditions of the Colorado River and what should we expect with Lake Mead's water elevation in the near future?
Sure. Thank you, Jason. And I just want to say first and foremost that it's an honor and a pleasure to be here on this panel with you all and with Doa and Erin. Thank you for having me.
Oh, thank you.
And I just also want to point out that, of course, the architects have the nicest lighting because I can't get this overexposure on my face. I just can't get it right. So sorry about that.
We try, Mike.
So first, before I talk to you about Lake Mead, first I want to tell you why the Colorado River and the Colorado River Basin are like no other river and river basin in the world. So the 1,450-mile-long Colorado River is the 5th longest river in the US and quite possibly, in my opinion, the hardest working river in the world. It flows through the hottest and driest parts of the country where water is vitally important and without it would be uninhabitable. Additionally, it's a losing river in that water from the stream bed flows into the ground to recharge aquifers and groundwater basins. Agriculture is the dominant use of Colorado River water, accounting for approximately 70% of total Colorado River water basin-wide used in the United States. And 40% of the river is exported outside of the basin's hydrologic boundary for use in adjacent areas. In fact, major metropolitan cities wouldn't be what they are today without exporting that water outside of the basin. So you have Albuquerque and Santa Fe, New Mexico. Sorry, Erin, if you're in either of those places. Denver and Colorado River Front Range cities, Salt Lake City, Utah, Los Angeles, San Diego. All of that water is located outside the hydrologic boundary, which means any water that drains in that boundary doesn't return back into the Colorado River. So it's extremely important. Hydroelectric power plants in the upper and lower basin have a total generating capacity of more than 4,200 megawatts, producing nearly 8,500 gigawatt hours of electricity per year. And finally, it's the largest river in the US that doesn't reach the ocean. So I just wanted to shape it up as a little bit of an underdog story to show what we're fighting for here and what we are spending our careers trying to ensure that we can help it continue to grow and thrive, or at least reverse some of the effects that climate change has had on the river. So Lake Mead and Lake Powell, the 2 largest reservoirs in the nation, are at historically low levels, not seen since initially filling. Flows during the past 23-year period of drought, so over 2 decades, beginning in 2000, are the lowest in the past 120 years of modern record keeping, and one of the lowest, if not the lowest, in the last 1,200 years of the paleo record. So extremely dry period we're in right now. And during the past 5 years, only 1 year was above average of inflow, and 4 of those 5 years ranged an inflow of just 37 to 63% of average, making it one of the driest 5-year periods on record. Lake Mead currently sits at about 185 feet of full pool, which is 27% full at elevation 1043. Lake Powell is about 170 feet from full pool at about 25% full at elevation 3528 feet. Lake Mead, which operates on a calendar year basis, is currently operating in its first ever level 1 shortage condition. I'm sure you all heard about that. It was announced in August of 2021. And that means that there was mandatory shortage reductions and water savings contributions for Arizona, Nevada, and Mexico in the amount of 613,000 acre feet, which amounted to around 7 or 8 feet in Lake Mead over the last year of vertical elevation it saved. However, due to the really dry conditions that we've been seeing, Lake Mead's elevation kept declining, and on August 16th of 2022, Reclamation declared the first ever level 2A shortage condition, which will start January 1st, 2023. And what that means is about 108,000 acre feet more of conservation and water savings contributions next year, for a total of 721,000 cumulative acre feet of conservation, again, by Arizona, Nevada, and Mexico. And that's the equivalent of around 10 vertical feet of elevation in Lake Mead. But it's not enough. So even operating under a 2A shortage condition, there continues to be an imbalance, and we continue to see and will continue to see Lake Mead's elevation drop about 20 to 25 feet over calendar year 2023. And we're projecting right now in our midterm models to be below elevation 1025 by next January 1st or December 31st of 2023, which means that we would operate in a level 3 shortage condition in 2024. And that is the most significant and deepest shortage condition that Lake Mead currently has on the books and in negotiated agreements. So that's currently where Lake Mead stands right now.
Wow. This is definitely a reality check, Mike. And Erin said we're not trying to scare anyone. Hopefully we can approach some good ideas. But I do have a question related to the elevation at Lake Mead. Is there ever a chance, or what is the possibility of Hoover Dam's ability to produce electricity that the water drops so low for that?
That's a great question. So there's a couple of key elevations that I want to point out in Lake Mead real quick. So full pool in Lake Mead is elevation 1229. That is the maximum water surface elevation. And in 1983, the high water line, so if you look at Lake Mead and you see that white band or that bathtub ring, that signifies the high water line in July of 1983 of 1225, almost 1226. So we were above the spillways at that point, and we were spilling water uncontrollably in the 1980s. So what I'd like to point out is that spilling is not great, but it was a good problem to have all of that water. Then in 2012 to 2018, when we started seeing these decline in projections and reduced lake elevations, we first started focusing on hydropower. And at that time, hydropower minimum power pool was at elevation 1050. Due to the installation from 2012 to 2018 of 5 what we call wide head turbines, which they run more efficiently over a wider head or pressure band in Lake Mead, they could run at lower elevations. We're able to move that minimum power pool rating from elevation 1050, which right now we're at elevation 1043, we'd be below that right now, to elevation 950. So we're still about 90 or so feet above minimum power pool right now. However, there's another elevation I want to point out, and that's dead pool, and that is elevation 895 at Lake Mead. So about 55 or so feet below minimum power pool. But to answer your question, and it's good news, so currently we do 5-year probabilistic projections every 3 or 4 months. So we do it 2 to 3 times per year. Our 5-year probabilistic projections that were recently released show that if operations remain the same in our reservoirs and hydrology were to resemble that of 1991 through 2020, there's only a 7% chance of falling below elevation 950 by 2026. And there's a 0 or negligible chance using that hydrology in those scenarios of falling below minimum power pool. Oh. So we certainly have some cushion and some buffer in Lake Mead.
Wow. Yeah, I remember those photos of the water overflowing, and it's a stark difference. And as we kind of said earlier, the mindset shift that needs to happen now. Then maybe we can switch to Doa, and Doa, you can give a little more insight to the historical context for Nevada's water rights, Southern Nevada's water rights. And a lot of us heard about this return flow credits and how that's guided policy. And maybe you can give an overview of what that is for Southern Nevada Water Authority.
Sure. So overall, from a share of the river standpoint, we are the baby at the table. We get 1.8% of the river. That's what we're allotted for our state. And actually, for the state of Nevada, really, it only means Southern Nevada, because other parts of Nevada get their water from other sources. But it is important to recognize that for the state of Nevada, probably 3/4 of the economic output come from Southern Nevada. So it's really important for Southern Nevada to continue to thrive, to support the entire state as a good portion of it. So we get a 1.8% of the Colorado River. And so what that means in terms of the full allotment is 300,000 acre feet. For comparison's sake, California gets 4.4 million. So, not quite equal in any way you look at it, but And a lot of people have asked, oh, if we go into negotiations, are we going to get more water? The answer is absolutely not. That's a hard no. We have to live with what we have. So out of necessity, Southern Nevada has been very innovative. And it's interesting to point back to kind of what both Erin and Mike were talking about, in that where we sit, specifically, if you will, Las Vegas, I'll just say that by proxy. But so for Las Vegas, we sit geographically within the basin where we use it and return it. So I believe, if I'm not mistaken, we're the only ones within the basin that actually do that. We don't transfer water out of the basin. It stays 100% within the basin. So because of the way our valley is situated, our source water is at a lower elevation, our use is at a higher elevation. And that means the wastewater we generate is at a higher elevation, but all the treatment plants to treat that wastewater are at a lower elevation. So as a whole, for the past 50 plus years, this entire valley has regionally recycled our water. And we don't even want to say wastewater, really. I mean, any wastewater not recycled is just water wasted. And so for us, we have to continuously recycle our water. Our water is forever going to be this way. So what we do is all of the development and existing users, if you pay a sewer bill in any way, shape, or form, you're connected to a sewer system. It doesn't matter what jurisdiction you're in. If you're sewer, North Las Vegas, Henderson, everything, it all gets returned to a wastewater treatment plant. It gets treated to near drinking water standards, returned to the Las Vegas wash, where Mother Nature does its best to clean it. It gets back out to the lake, and for every gallon we return, there's another gallon we can take out. And this is important for us because, as I mentioned, our full allotment is 300,000 acre feet of water, which under the new level 2 shortage will be allowed to take 275,000. But as a community, for example, last year we delivered over 560,000 acre feet of water to this community, but we actually only removed and never returned 242,000. So if our allotment next year, our legal entitlement that we're allowed to take is 275,000, and right now, based on our current projections, we're looking like we might finish this year using 228,000. That difference is everything we've done in conservation. That difference, it means development opportunities. So recycling, and I say recycling, like a lot of people need to get their heads wrapped around the fact that you flush your toilet, you take a shower, you do your dishwasher, you run your clothes washer, whatever it is, all that water, if it's captured by the sewer, is treated, cleaned, returned. Then we pull it out, we treat it, clean it, and send it back out. So it is a full cycle. And we are truly fortunate to have that regionally in Southern Nevada, because without it, we would have stopped growing and came to a complete stop probably about 20 years ago, 22 years ago, probably.
Wow. And so we all heard the adage about reduce, reuse, and recycle. So we just talked about the ultimate recycling machine we've implemented. You also mentioned, Doa, on the innovations, and maybe
Yes.
we can jump into that a little bit on water consumption and on the reducing side. What innovations have SNWA recently implemented?
Well, we, it's important to understand that every year, Southern Nevada Water Authority does a 50-year water resource plan. And we do this so that investors and development and everything else can make a educated decision as to whether or not they should invest in anything in Southern Nevada. Typically, you want to know that you can at least clear 30 years. So we do a 50-year look ahead. And we take that hydrology that the Bureau of Reclamation does. We also run our own hydrology. We tend to be a little bit more on the pessimistic side. We plan for the worst. And but we also have to take in consideration the amount of available land to be developed, what could be developed, And you know, based on UNLV, CBER, and so forth, we see that in the next 50 years, we could have over 4 million people living in Southern Nevada. So with that, how do we continue to develop with our small little share of water? And anything that's not returned to the wastewater system, obviously, is what we consider consumptive use. We have to reduce consumptive use in order to allow for continued development. As an example, last year, I think we added over within the valley last year and this year so far, we've added over about 30,000 new services, new connections, brand new services, yet we reduced our consumptive use by 10%. So our conservation measures are all targeted at consumptive use. If it's not getting to a sewer drain, then it's consumptive use. And we have to make every single step possible to reduce that. So within our most recent resource plan, we proposed a step down chart with many different topics. And we went after just about every sector of our community, kicking everyone in the shins to loosen up or tighten their belts, I should say, and reduce the amount of water. And a lot of those have been met with some resistance, but overall, because of these, that's what's going to help us get to that goal of that 86 gallons per capita per day. That's adding in an additional usage as a result of climate change and heat. So we're fighting against system age, we're fighting against, climate change and growth. So we have to reduce all of the consumptive use. And a lot of those have included no more new golf courses. We're tightening the belt on the budget of golf courses, no pools larger than 600 square foot for any residential dwelling. No more evaporative cooling and swamp cooler type situations on industrial or commercial type buildings. We eliminated turf in all new homes, front or back, doesn't matter. No new turf unless you're a school, a park, or a cemetery. Non-functional turf, we became the first state in the entire country to ban watering non-functional turf. It's become illegal. And as soon as that law passed, 5 states asked us for the language because it's a no-brainer. It really is. You don't choose your gas station based on which one has a strip of grass in front of it. So those types of measures we're taking, they're tough and they're hard for our elected officials to press those green buttons, but it's necessary for Southern Nevada to survive.
Wow. I want to, it sounds like we're doing a lot here. And I think the Southern Nevada Water Authority needs a lot of praise for the work they've done and the measures they've taken. And I do want to circle back, Mike, you mentioned this concept of Deadpool, because this might help with the Ned. What does Deadpool mean? Can you do a quick explanation on that?
Yep. So Doa said it perfectly. It's where the Colorado River stops at Hoover Dam. So essentially, water cannot be passed beyond Hoover Dam by gravity. You'd need to pump it or do some other measures to get water downstream of Hoover Dam.
Right.
But there's still 2.5 million acre feet in Lake Mead.
So essentially, Southern Nevada has access. The downstream communities, California, Arizona, Mexico, do not. I'm sure we talked about this notion of mindset shift and reality check. What kind of political things happen when we get to that level? Doa, maybe the political pressure of if we have water and other communities don't. What do you see happens there? Is that get people started, other communities started, and
well, I think
conservation?
I think the fear of hitting Deadpool is a motivator in itself, right? As I mentioned, we've historically been a little bit on the pessimistic side of Mother Nature's delivery of water. So we've continuously modeled the Colorado River, especially with respect to Powell and Lake Mead, assuming worse conditions. We've taken into consideration climate change, added on even worse factors. And so everything that the Bureau of Reclamation gave us, we said, I think it's going to be worse. I think it's going to be worse. And we've continuously done that. And because of that, we saw that we were going to be losing our first and possibly second intakes way back in the early 2000s, which is why this community invested over $1.5 billion in a third intake and a low lake level pump station with the hopes of never having to use them. But we figured that if worse comes to worse and Mother Nature just continues to flip the thermostat up on us and doesn't give us any sort of runoff, that we need to be ready. And we are in a position to be upstream of the dam. So we put that third intake on purpose 20 feet below dead pool. So although we have 1.8%, we are the tiniest little user of the Colorado River. We made ourselves the strongest position in the entire basin to have guaranteed access to our water.
Right.
And if we hit dead pool, California, Arizona, and Mexico are in a world of hurt. I recently was on a panel discussion regarding water scarcity. And interestingly enough, it was myself and Adele, who's the general manager for Metropolitan Water District. And that question was asked at the audience. Somebody said, what happens if Lake Mead hits dead pool? And Adele says, we die. I mean, like literally, they run out of water. And I said, well, Southern Nevada's okay. I don't want to say we don't share the same problem with respect to drought and aerification, but we're upstream of the dam with a solution, a physical solution. Everyone else downstream has got a hope and a prayer. So what happens is if we get closer to dead pool, the motivation factor on everyone downstream is going to be really strong. They are going to be very motivated to keep water in Lake Mead.
Well, thanks for explaining that. And so as we continue, we talked about growth. We talked about expected population growth, Las Vegas, and even regionally. So what are additional actions that we can expect that are being considered by Southern Nevada Water Authority and Bureau of Reclamation? And maybe Doa, you can start there. And then Erin, I want you to start thinking about what has been done elsewhere in this context and what might we consider.
Well, I can definitely start with, first of all, Southern Nevada Water Authority doesn't get to determine whether or not development happens. It's not our decision. Our role in development is to advise the elected officials what is necessary, is there water available, how long can we continue this? And so by doing that resource plan, we're able to keep them informed so they make better decisions. But some of the things that you can anticipate that are already in the process, among those changes that I already mentioned, one of the big key things is we are now at the very beginning of the evaluation process with the Governor's Office of Economic Development, as well as the Las Vegas Global Economic Alliance, as they're looking at trying to court businesses and industries to come to Southern Nevada to establish their company. One of the first questions we're asking, and we created basically a form that they have to fill out information regarding their amount of water, their footprint. Now, it's not to say we're going to say no to somebody who might use a lot of water, but if you're an industry that uses a good chunk of water, but they're also going to produce, 20,000 high-paying jobs, then it's a better investment for the water. But we turned away one of the largest bottling companies because we said, unless you can guarantee the water that you're using for your bottled product is sold, consumed, and flushed in Southern Nevada, we're not doing it. And we sent them away because it's an automated process. It doesn't generate a lot of jobs, and all it does is export our product. So that kind of conversation has to happen. But coupled with that, we are actively working with innovative solutions out there to find ways to do different types of industries and technologies with a reduced water footprint so that we can attract those types of businesses here. It's just that we have to tell people that if you're just in the business of shipping out our water or using it and wasting it and letting it evaporate, you probably want to go somewhere in the Midwest or East Coast.
I'm happy to hear that you're working with other agencies, because I mean that's what it takes. From a macro level, you can only affect so much with here. Mike, do we have you back?
Yeah, sorry, my computer up, so I joined from my phone.
Oh,
Yep.
no problem. You're coming across just fine. Do you
Better
want
now.
to do you want to answer this question? What should we expect in the future for Bureau Reclamation, and what things are you doing, planning or in the planning stages?
Sure. So federally, I think things are a little bit different because the water belongs to the states, not to the federal government. However, in the lower basin specifically, the Secretary of the Interior is the water master of the last 688 river miles of the Colorado River. So that's from Lee Ferry, Arizona, the Compact Point, down to the border with Mexico. And that puts the Secretary in a unique position, as she serves currently as a role of similar to state engineers, and the Boulder Canyon Operations Office, on behalf of the Lower Colorado Basin Regional Director, fulfills that mission. So some things that we've been doing, you've heard, we've gotten an unprecedented amount of funding from Congress. So through the bipartisan infrastructure law, through the Inflation Reduction Act, we've received for Western drought over $4 billion to be used essentially in the Colorado River and the upper and lower basin, Colorado River Basin. I think in total, it's between the two together, it's over $5 billion, but just in the Colorado River Basin, it's over $4 billion. So the money short-term, Reclamation and Interior is using that for compensated conservation projects. But the goal is to fund larger infrastructure type projects that'll help with conservation on a recurring basis. So essentially you pay one time and you get a recurring benefit from it. However, in the short term, due to how dire the situation is and how quickly it's declining in hydrology, what we're trying to do is essentially this compensated conservation program is essentially paying farmers to fallow their fields, so reduce consumptive use in California, Arizona, and some of our tribes as well. And we'll continue to work with our partners in the states of Nevada, California, Arizona, Mexico, tribes, NGOs to develop other opportunities or methods to continue to use this funding to help either them with their projects or to pursue new federally sponsored projects.
Oh, great. So Erin, I want to give you an opportunity to weigh in, and then maybe we can take a few questions from the audience, Craig. So I know there's a few in the queue, but Erin, what do you see from other states? And now that you heard a little bit about this system in more detail from our experts, what do you think we could also be doing in terms of the future solutions?
Sure. Well, on the whole, I think there's no one silver bullet to these challenges. And I think a systematic, broad perspective is needed to figure out how this is going to require a lot of like paradigm change. And so we need to embrace both these technological infrastructure driven solutions, like Nevada and particularly Las Vegas, I think are actually models for how to take all the low hanging fruit off the table with water use and how to really implement water recycling. I think, people are surprised to learn that Las Vegas is that progressive, but it's really a compelling story. So one, I think continuing that piece, and the Southwest is looking at what Las Vegas is doing, and there's some other cities moving in that direction. But it's easy to kind of focus, I think, on the infrastructure solutions and forget the larger watershed and habitat and ecological conditions too that are supporting the water that's coming down, all of these various places that people in the Southwest are pulling water from. In New Mexico, for example, in Santa Fe, even though we have somewhat only recently tapped into the Colorado River, which many people here are not happy about that at all, most of our water historically has come from either the Rio Grande or from our watershed. And so we do a lot of work on enhancing and restoring the watershed in the forested mountains, doing, fire management and prescribed burns for better or worse, and managing, the ecosystems that we need to have, intact for that water cycle to support us. And so I think that it's easy to lose sight of that, and we turn on the tap and we forget that there's this whole, you know, underlying ecosystem that supports all of our ability to live where we live. And so even for designers who are working on a site scale, like there are different reasons for why we would want to invest in water conservation or reuse or recycling. You know, there is the economic value that Doa talked about, or avoiding things like dead pool that Mike talked about, which sounds also terrifying, right? But there is this idea that like water has inherent value, and it's needed in our rivers and in our streams and in our creeks to protect, you know, aquatic species, avian species, all the birds that migrate through. There's this whole richness here in the Southwest that also depends on that water. And so within our firm, this is a big focus of like why. It's like connecting the urban users and designers to like these larger ecosystem understanding. It to me is a big driver, and that's why we don't like the fear-based, you know, incentive. It's like important to know that, but it's also like a real opportunity we have to make sure that we're also investing in water, you know, river and wetland restoration. Some interesting things happening in Arizona with that. So Arizona is a state that has some geology that's really conducive to recharging groundwater. And so, you know, looking at opportunities for when it does rain there, big monsoonal pattern, you know, getting as much of that water back into the ground as possible. There's some pretty basic ways to do that that don't have a lot of ecological value, but there's also ways to do that that are creating wetland habitat and that are restoring riparian habitat and creating open space and parks, places for people to be, recharge water, and sort of have this, you know, nature-based solutions for managing water. And so those types of systems and opportunities, I think, are going to enrich the ability for people who live here, while we also shore up our water supply with the technological techniques that Doa and Mike are talking about. It's incredibly complex. But one last thing I'll share that to me, people always are like, you live in the desert, how are you a water engineer? And I feel like in northern New Mexico, anyway, there's such a richness of both like Hispanic culture that has lived here for a very, very long time, 400 plus years, and Native American culture has been here even longer. And they both have, I think, influenced how water is managed here in northern New Mexico. And so like acequia culture is very interesting. It's a democratic way of sharing water for irrigation in ditches, acequias are called here, where, you know, almost all that water is kept within the little riparian zones from which it's pulled out, and it's almost all recharged. There's incredible return, even though there's irrigation happening. And it is also like uplifted all of this riparian habitat for birds and migrating species. So it's an interesting cultural and ecological solution. And then, you know, working with a number of Native American pueblos here over the years, there's a strong current of the need to recognize that right to water, or that right to clean water for everybody. And I think that that's important, not to lose the value of like the indigenous people here who have this perspective of like, we all need to figure this out. And that, if we use that kind of thinking, for me, for designers, really helps people like make good choices, right? And not just scare people.
Great. Craig, and maybe we can ask a few of the audience questions.
Yeah, we actually have some really good ones. So it's a little bit long, but I'm going to read it to you guys. Say, can someone please talk about the need to simultaneously reduce water use and carbon emissions by reducing the amount of water we pump and treat? The water energy nexus seems to be getting lost in the discussion about the ongoing drought and climate change. I thought I had read somewhere that the Water Authority was the largest energy user in the state. Doesn't know if that's correct. Maybe you can answer that one if we can here.
I can definitely speak to that. Yeah. With the exception, I think, one of our pump stations that does have some natural gas pumps. Everything else is electric pumps. But the power water nexus is absolutely built into everything we do. Every decision we make to operate our system is made with a goal of the lowest possible amount of power needed. So first of all, when it comes to, we don't just flip on a bunch of pumps and let them run. We actually do a series of pump turn-ons. We do them in an order so that we run them the most efficiently so they're not draining power. And with even if it's a slow roll of moving water, it's a low power draw. We'll do that. And that's why we have so many reservoirs, because we will feed everyone through gravity. We only pump to fill the reservoir, and then that's it. Pumps go off. And additionally, we were probably one of the first in the state to help NV Energy meet any of their alternative energy goals, by the way, because we have a bunch of our reservoirs that have solar panels on them. Our treatment plants have solar panels. The Springs Preserve has solar panels. And we also are constructing a major solar facility that will bring our portfolio to over 55% renewable energy. So it is very important for us to be able to reduce that power draw on the system, but it is absolutely, as a matter of fact, our operators are going to have to change the way they think when we go with so much solar, because right now they think in terms of, I need to go a slow roll, and I do it at night when nobody else is drawing off the grid, because that's how we prevent any sort of power surges. That when they're rolling off of solar, they got to flip things on quick and full power during the day. So it's gonna change the way they look at things. But we have sustainability built into our core values, and every single pump station, every pump we look at, everything has to take in consideration that carbon footprint and how can we reduce it in every way possible. So we even go as far as to designing the pump stations that we take the smallest pumps necessary without having to pull too much power. So it is absolutely built into us. I can't say that we are not. I do believe we are the largest users of power as a whole, but when you consider how much we're delivering water, and everybody's use of water is above its source. So we have to pump no matter where we are, but it is important to us.
Wow.
Let me ask another quick question. He says, I recall in state of Nevada on NPR that tree ring studies indicate the Colorado River Basin is typically dry, and that the design of the dam and the first 30 to 40 years of the dam were the wettest on record. We're now in what would be considered usual dry times for rain and snow. Maybe somebody can address that one.
Yep, I got that. So during the negotiation on the Colorado River Compact in 1922, which essentially is the cornerstone of the law of the river, which governs the operation of the reservoirs, Lake Powell and Lake Mead specifically, but all the reservoirs on the Colorado River. It was negotiated at a time, what they call the early fluvial period, which means an exceptionally wet period. And at that time of the negotiation of the compact, it was assumed that the natural flow of the river was 18 million acre feet per year. And it divided up the river to 7.5 million acre feet to the upper basin, 7.5 million acre feet to the lower basin. And at that time, they used 1 million acre feet as a placeholder to Mexico, which later in the 1944 US-Mexico Water Treaty, Mexico actually got an allotment of 1.5 million acre feet. So in a year, 16.5 million acre feet is allocated annually. And again, during the Colorado River Compact negotiations, it was assumed there was about 17.5 to 18 million acre feet. When you look at that record from 1906, that's the very first of our modern records till today, that natural flow record is actually around 14.8 million acre feet. When you reduce that record to 1988 to 2020, 2021, which is certainly the period of, we call it the stress test record, or the period where we started seeing warming temperatures in the basin, that amount decreased to about 13.1 million acre feet. And then if you decrease that period of record to just the drought period of 2000 to 2021, you're looking at around 12.8 million acre feet. But if you decrease that period even further to 2013 to 2022 provisionally, it's only 12 million acre feet per year of natural flow that we're seeing. So I do agree that they knew early on that the Colorado River was highly variable, that there would be periods of drought and periods of surplus, which is why Lake Mead and Lake Powell are designed to be the two largest reservoirs in the world and combined storage capacity was about 60 million acre feet in the Colorado River system. That would store roughly 4 times the natural flow of the river, 15 million acre feet or so. But over that 1,200 year period, when you go back and look at it, and you look at the 23-year period consecutively, dry years, and I don't have a handout or a visual in front of me, but this is one of the lowest 23-year periods. And that's why, knowing that we are where we are with carbon emissions and climate change, we consider this aridification, and we don't see things necessarily rebounding to the point where they have perhaps 1,000 years ago. But things are still uncertain. We don't have crystal balls. We cannot say certainly that, we will never go back to where we were, but we do know, based on these trends and the trends I just showed you, by shortening those periods of record, things are getting drier. They're not getting better. They're going in the wrong direction. So hopefully that answers your question.
Thank you. Do we want to jump to more questions, Craig? Or
Let me do one more, because I think
Okay.
this one would be good for Erin to talk about a little bit. Are other states using the same water source, taking regulations that we do? And I think they're referring to more of the recycling kind of an approach.
Good question. I think that's what that question means. What I can say is that there is some effort to create more consistency for water reuse and water recycling, and to both simultaneously like advance the technology and the policy to like open up the opportunities for that intensive water recycling. Because as Doa has pointed out, like there are allotments of water there, and as Mike has noted, they're not going to get bigger. And so this water recycling has a lot of variability from state to state right now. And there are several organizations, Water Reuse is one of them, and then the U.S. Water Alliance is another one, who have been working at the policy level to help provide model codes and standards for both decentralized, sort of like on-site water recycling, as well as to push some unification in the water utilities and at the state level to allow for both water recycling for non-potable use, for like toilets and irrigation, relatively low-hanging fruit, non-potable water for indirect potable use, which is I think what Las Vegas would be considered. It's mixed into a natural source of water and then reused. And then there are some places that, and it's coming, where there's direct potable reuse, where it's literally going from the treatment plant to a water treatment plant and then back. And so those codes right now vary state by state, and the practices and the public perception and acceptance of that also varies quite a bit. And so that infrastructure is expensive. And the comment about the energy water nexus is a really important one here. And there's also one about cooling towers I saw on there, that it is important to note that like right now, most of the technologies to produce this really clean water from our dirty water has a pretty significant energy footprint to it. Okay, it's a pretty intensive process, wastewater treatment, and then the final stages through membranes. And so that technology is improving, but there is definitely an energy cost to this whole equation. And removing cooling towers is one of them. And so on the whole, part of the way to think about this is that we need to improve our buildings and the way that we mass our buildings and the way we build our communities to like not require as much cooling, to have a revolution in that way that buildings are designed. With Casey Galati, you guys have done some great ones with that, right? Rammed earth, and that movement is happening all over to make sure that we're not just building buildings that take a ton of energy and a ton of water to run. And so those things all come together. But certainly all the states are looking in the Southwest are looking at this water recycling thing very seriously. Not everybody has a setup like Las Vegas, which allows relatively easy return. And so it's going to be modeled. You're going to see some cities that do it, and then you're going to see some that don't or can't. Like in California, the timeline to provide purple pipe or recycled water can be years and millions of dollars. And so there is the opportunity for designers in certain situations to take that up the decentralized scale. So districts, stadiums, malls, even like, apartments, doing water recycling there is a very good intermediate step as these other infrastructures are coming on board. You just need to be mindful about the energy cost because it's not insignificant. So those are, you know, what we see happening, and it varies. You know, Texas is somewhere different than California, but they're all moving in that direction.
Yeah. Well, thank you, Erin. I think you're touching upon, like, actually we can bring some of this back together about what can designers do. And that was a question we had lined up. And you mentioned the evaporative cooler, doing better buildings in general to reduce need and use. But Doyle and Mike, I wonder if you also have anything to add about what, as designers, architects, engineers, what should we be thinking about when it comes to ways we can conserve water?
Well, I know one of the things that I've mentioned, and actually I've tasked some of our staff to start going after it, is, you know, for a long time, it's been super awesome and sexy in the community to go after a LEED certification. The U.S. Green Building Council doesn't do anything in the desert Southwest to preserve water over power. In fact, all of your building ratings are about how low your power footprint is, and who cares about water, which is why we ended up in the situation that we are in. And we didn't really truly know how much evaporative cooling used until we had the COVID shutdown. Because when the resort corridor shut down, not one single visitor allowed in any of those hotels. Nobody is dining, nobody is showering, nothing. And we saw only about 2/3 of their water use drop. What's that other 1/3? It's cooling. They kept their buildings still cool. And after talking with a lot of the facility managers in these buildings, and I'm not picking on hotels, all the way across the board here, data centers, it doesn't matter. They'll tell you that it's way cheaper to burn water for cooling a building than it is power. And so how do we change that? We need to change that philosophy. And I said, you know, why can't we start with the green, you know, U.S. Green Building Council, get them to make a different standard for the desert Southwest, because we can make more power. We can't make more water. And that's the position we're in. We're building solar like crazy because we get sun 364 days out of a year.
Right.
You know, we can do that all day, every day. We can put it on every building top, but it doesn't make more water. Water scarcity is our natural disaster.
And I know we're running out of time. I just want to squeeze one more question in, because I think you talked about it with, you know, the resorts. What can, you know, it's one thing to implement strategies on new buildings and new construction, new places. What about what can we do with existing infrastructure, existing buildings? You think of all the hotels, you think of septic systems that just take water and not return it into our system.
Right.
What's happening with that? What can we do about that?
Well, on the existing buildings, first of all, SNWA, I mean, we're probably the only industry out there that will pay you to not use our product. And so we give money, we through our water efficient technology program, we give money to help cover the cost of converting systems. So for example, the Ocean Spray plant in Henderson, you know, they not only do they bottle our product and ship it out, but they've been here forever, so they're grandfathered in, but they also had evaporative cooling. So they raised their hand and said, I would like to convert my system. I want to do the right thing. I can't stop that I export product, but let me at least reduce my water use on the evaporation of the cooling system. So we have money to give to them to help offset that cost. And we just upped that amount as well. Additionally, we're working with innovation companies throughout the world. We're talking to people like Singapore, PUB, everywhere where they're equally in Mekarat and Israel. We're talking to anybody and everybody to find out, how are you able to cool your buildings and capture the water so that you don't lose it? And any new technology coming forward, we're willing to work with anybody who's got these systems. The first thing that we needed these properties to do is be willing to sub-meter their cooling system. We know how much they get into it, how much gets captured through blowdown. The delta is what we're losing. And that's what we need to know, the true number of what's going out and what can they do within their own system. For example, one facility manager for one of the resorts says, when it's 115 degrees outside and you walk into a hotel casino that's 68 degrees, it's still going to feel cool if it's 69.
Yeah.
And that 1 degree change saves tons in cooling. So just sometimes changing that will help. On the septic part, that's a challenge, because the whole purpose of a septic system was to kind of band-aid the process. Somebody bought a parcel a little too far away from existing sewer mains, so they get to use a septic system. The intent of a septic is only meant to be temporary. It's supposed to be temporary until sewer becomes available. Yet in this valley, we've got almost 15,000 parcels with septic systems, many of which have sewer right outside their door. So we need to work with the property owners, the health district, the local agencies to get people to convert. And part of that is a cost. There's a significant cost to that. So we're going after federal, state, local, any funding we can, because every drop of water we deliver to a customer who has a septic tank is 100% consumptive use. We get zero of it back. So if we can just get them connected to the sewer system, then it saves two things. It saves our resource, but it also protects the groundwater, which is being contaminated from an excess amount of septic systems out there.
Right. Well, thanks for explanation. We have a lot of questions, and I think we're gonna have some follow-up to this, because this is, I think we overshot thinking we can fit it within an hour, but we want to be respectful of everyone's time. Really appreciate you, Mike, Erin, Doa, a great panel, very informative. And we'd love to maybe down the road have you back again to kind of pick up the conversation, because I don't think this is going away. I appreciate everyone for joining us today. This is our last Fireside Chat of the year. We'll pick up in the early next year or next one. Be on the lookout for that invite. Appreciate everyone joining us. Thank you all.